Hi there, welcome to this video where we're going to take a look at a problem from a mathematics admissions test, and we're going to be taking a look at the 2021 mathematics admissions test past paper, the MAT, and it's question 1G that we're going to be taking a look at. So this is one of the multiple choice problems, so it's nice and short, but I thought it was a really interesting problem. It took me a few minutes to figure out exactly what to do with it, so I just wanted to make a video just to go through it. So if you are preparing for MAT exams or STEP exams or anything like that, and you do want a little bit of extra support, then I'm making these videos on this YouTube channel. But if you want a little bit more one-to-one support in that respect, please get in touch, because I've got plenty of experience dealing with STEP, MAT, preparing people for these exams. I'd love to hear from you, so I can know what your expectations are, what your requirements are, and have a discussion with you about how I can help you. Feel free to get in touch. Okay, so let's have a look at the problem. So it's 1G, and we need to find the sum of this series. So sine squared 1 plus sine squared 2. These are in degrees, by the way. So 1 degrees, 2 degrees. Sine squared 3 degrees plus up to and including sine squared 90 degrees. Okay, and we're given some choices. We're given 5 choices. Is the sum equal to 44, 44 and a half, 45, 45 and a half, or 46? Don't just guess, because that's not what your examiners are looking for. Understand that with the MAT, even on the multiple choice questions, it's not about just circling the right answer. Okay, it might even say, I can't remember what it says on the front cover of the test papers, but it might even say something to that effect, that if you don't show any working, you might be given little or possibly no credit. What your examiners are looking for is, can you show how you've arrived at your results? Because that really is what mathematics is about. It's about showing evidence and justifying how you've obtained your outcome. So if you just kind of circle one of these possible responses, one of these 5 possible responses, it might happen to be the right one, but there's no skill involved in that. You've not demonstrated your understanding of mathematics or anything like that. So your examiner's not going to be interested. You have to show some working. And obviously your working has to be consistent with the answer that you give as well. So again, don't just kind of write something down so it looks like you've done some working and then just circle an answer. Your examiners are much smarter than that. They'll see straight through something like that. Okay, so this is not an arithmetic series. It's not a geometric series. So you can't use the theory, or at least it's not recognizably so. It's not recognizably arithmetic or geometric series. So you can't just use some of the kind of standard theory. You've got to be a bit more creative. And this is a really good problem that kind of tests you about how creatively you can use what you know. Okay, and how well you understand. So even though it's a fairly simple problem, when somebody shows you what to do, potentially it's going to seem very straightforward, but actually coming up with the solution yourself is an entirely different thing, potentially. As with a lot of problems, a lot of times people will come to me and they'll say, when my teacher goes through problems in class, I understand exactly what they're doing, but then when it comes to solving problems myself, I can't do it. Very common thing. Well, because these two things are not the same thing. It's like watching a football match on TV and playing a football match. These are not the same thing. It's very easy to sit and watch a football match on TV, and it's quite difficult to actually go out and play a football match. In fact, I would say it's very difficult to do that. The same applies to watching somebody solve a problem and solving the problem yourself. Okay, so anyway, I'm going to give my solution to this problem, and what it comes down to is creative use of a certain trigonometric identity. Which one? This one. Cos squared theta plus sine squared theta is equal to 1. Okay, so, well, okay, it's identically equal to 1. So understand that this is not an equation. I'm sure you're aware of this. This is an identity. It applies for all values of theta. Okay, so in other words, sine squared 1 plus cos squared 1 is equal to 1. Sine squared 2 plus cos squared 2 is equal to 1. Up to sine squared 89 plus cos squared 89, and you'll understand why I'm only going up to 89 in a second, is equal to 1. So therefore, adding all of these together, what do I get? I get sine squared 1 plus cos squared 1 plus sine squared 2 plus cos squared 2 plus sine squared 89 plus cos squared 89 is going to be equal to, well, how many numbers are there? There's 89. 89 numbers. Okay? But now, bear in mind that, let's say we've got, what is it, sine 90 minus theta. Sine 90 minus theta, and just to show you how this, why this is true, we've got sine 90 cos theta minus cos 90 sine theta, using another trigonometric identity, which is just cos theta. In other words, sine 90 minus theta is equal to cos theta. So therefore, cos squared 1 is going to be equal to sine squared 89. This is going to be equal to sine squared 88. This is going to be equal to sine squared 1. Okay? So, in other words, I get, I can kind of reorder these a little bit, and I get 2 sine squared 1 plus 2 sine squared 2 plus all the way up to 2 sine squared 89 is going to be equal to 89. Not quite done yet. If I divide through by 2, then I get sine squared 1 plus sine squared 2 plus up to sine squared 89 is equal to 89 divided by 2. 89 divided by 2 is 44.5. I hate using mixed numbers, but that's what we're using in this. The possible answers to this are given us in the form of mixed numbers, so okay, whatever. Right, I realise that I've missed off a number, sine squared 90. Okay, so sine squared 90, adds that on. I get sine squared 1 plus sine squared 2 plus plus sine squared 89 plus sine squared 90. Well, sine 90 is equal to 1. So sine squared 90 is also equal to 1. So add 1 onto this, I get 45.5. Okay, so in other words, this sum is equal to 45.5, which is D. Okay, option D. And that's it. A nice, short little problem. Easy peasy, but a nice, interesting little problem as well. But this is the kind of thing that you will have to show, even when it's a multiple choice problem. You'll have to be prepared to show some work. I'm not saying that your working has to be exactly this, but it has to be something that at least gives some idea how you arrived at your answer, and that the working that you show, that you demonstrate, does actually point towards that answer as well, kind of logically points in that direction. Okay, so if there's anything that you're not clear about, please leave a comment in the comments section. If you do find these videos useful, please subscribe to this channel, show your support by subscribing to this channel, share these videos with anybody else that you think might find them useful, and don't forget to hit the like button as well. So that brings us to the end of this problem, and it brings us to the end of this video. Thanks a lot for watching.